Hi, good morning, students. How are you?
Good morning. I'm fine, teacher.
Very nice. Do you have any doubts from the previous classes? Do you have any doubts from the previous classes? No? Okay. So let's start. Okay, yeah, please tell me. I didn't hear. Did you say yes? You have doubts or no?
No, thank you.
No? Okay, very nice. So now let us start today's session. And today's session will be the continuation of the descriptive statistics. Okay. So let us start. So what are we going to learn today is we want to learn the group data. How do we perform mean, median, mode, and also how do we calculate quartiles, deciles, and percentiles. Also, we'll see how do we calculate standard deviation and variance. And at the end, we'll see how to deal with multiple variables. So we have multiple variables. How do we get some information from them? What I'm talking is covariance and the correlation factor. Okay. So before going that, let us see how do we prepare the group data. We already started with this. We prepared the group data last time. So let us do it again. So let me show some group data. I'll share my screen. Okay, so it's working now. Okay, so now let's see at this data. This data is the information collected from the website called Imbd. It collected the ratings of the video series called Squid Games. So it is the ratings given by the users for the video series Squid Games. So I want to prepare it in a group. So I want to prepare group data from this. So how do we prepare group data? We first create. Okay, before preparing the group data, let us see different the terminology of the group data. So if you see the terminology, we use this very in common. Class boundaries. The class boundaries have lower boundary, upper boundary, midpoint. So what is lower boundary and upper boundary is, so if we have any number in between this, we add as a frequency here, right? So for example, 0 to 10, if we have any population between 0 to 10, we add into this frequency. Okay, the midpoint is the middle of the lower and upper boundary. In this case, it is 5. Okay, how do we decide the limits? The limits is all the populations above or equals to 10 and less than, sorry, above and equals to 0 and less than 10. In the same way, we have the limits for all these class, all these classes. And then let us see the frequency. Now, what does the frequency means? How many times the population is in this range. So what is the population which falls in this range, right? So for example, there are 3 people or 3 data elements in this range. So this gives us the frequency. And the cumulative frequency is, we already know the class boundaries, or we are organizing in an ascending order. So once it is having in an ascending order, so we add the frequencies above it. So what do you mean by above? So it is an ordered way. So we have 3, and this frequency is 3. So it's the first one, so we don't have anything else to add. So we write 3. In the next one, we add 21, which is the frequency of that class, and all the elements above it, all the frequencies above it. What is the frequency here in this case is 21 and 3. So we add 21 and 3, we get 24. For the third row, or for the third class, we have 26, and then we add all above it. So we add 26 plus 21 plus 23, which is 50. In another way we can do is we add just 26 and 24, because 24 is already sum of all these elements, all these frequencies. So we can say 24 plus 26 is also 50. And how do we get 59? By adding 9 to the 50, we get 59. So in this way we can calculate the cumulative frequency. And now let us see what is this I means. Why do I say I here? I here in this case, I wanted to show that which row we are talking. The row 1, 2, 3, 4. So for example, if I say upper boundary of the second row or the second class, I say U2. The U2 is 20. So if I say X3, so what does X3 means? X3, the third 1, 2, 3. So I'm talking about the 25. If I say what is F1, you want to say it is 3 because the frequency of the first class. If I say C3, the class of the third row or the third class, which is 50, right? So let's prepare the group data from this. So for group data, we have to select upper boundary and lower boundaries. Let us say we select upper boundary and lower boundary with 1, or we can say we want to, these numbers are integers, right? So I want to say, I don't want to make any data to be lost. So I'm going to do is, first this data set I'm going to do is, I'm going to put just the class like this, taking into account all the numbers. All the numbers, I mean all the possible values I can get. So these are all the possible values are 1 to 10. So I'm taking everything into account. Then let's see the frequency. How do we calculate the frequency? We see frequency is equals to if the range is greater than or equals to this one, and then we subtract with the next one. So we get 69. So we get like this. So we see the total is n. Sum is n. We have to see here the total n represents the total population. So here, what is the total population? If we select here, the Excel counts for us. It says 11585. So the total should be 1185. So if I do sum, it shows 1185. This is the total population, right? So here I have the group data. So let me do another group, but with lower and upper limits. So let's say L and U, and let us say it starts with 1 and ends with 3. So here is This is because our group data starts with 1 and ends with 10. So this takes the whole range. And the frequency, so we calculate the similar way. I'll copy here. This number, the lower limit we put here, and the upper limit you can put here, not a problem. And now let us do this. The total is n again, and which is sum of all this, which is 1185. There are 1185 users who reviewed the Squid Games, and this is the group data. And from this we can find what is H. What is H? H is the class height or class width, or the difference between upper and lower boundaries. In this case, H is equals to the difference upper boundary minus the lower boundary. 2. This 2 is common for all the classes. So the difference between 3 and 1, difference between 7 and 5, difference between 11 and 9, all is 2. So we take it like this. So this is how we prepare the throughput data. Now let's see how to calculate relative frequency. In the next class, we are going to learn about the probability. In probability, we have something very similar to the relative frequency. So pay a little more attention to this so that you can understand a little bit more into the next class as well. So what we say relative frequency, let us say relative frequency RF. The relative frequency is, let us see the formula, what it says. The relative frequency is Fi divided by sum of Fi. What is sum of Fi? Sum of all the frequency. We know sum of all the frequencies should be equals to the number of data elements, which is n. So for Fr, the relative frequency for each class is Fi divided by n. So what we say, if it is Fi, so we have Fi divided by n, which is this now. So we get this is the relative frequency. So when we copy, it's giving divided by 0 error because I am copying. When we copy in Excel, both the rows are changing. I mean, here I wanted to divide 99 by this number, but here I want to divide 72 divided by the same number here. So to not move around, what I can do is I can put an dollar symbol. If I put a dollar symbol in front of a row, it stops moving the row. If I put in front of a column, it stops moving in front the column. In this case, I just want to fix the row, so I can put like this, and I'll copy down, and it calculates the relative frequency. And if we add all the relative frequency, the result should be 1. Kind of we are normalizing the data, the frequency. So we add all this, we get equals to 1, right? So let's find relative frequency for this case. The relative frequency here is divided by, I said, 16. It's the relative frequency. And if we add all the relative frequencies, it should be 1. We are getting 1. Okay. The relative frequency, let us show in terms of percentage. What do I have percentage? Percentage relative frequency. What am I going to do is we multiply this with 100. With 100. We get this like this. So let's do the same with now let's try to understand what it says. It says the relative frequency is 5, 2, 3. These are in percentages, right? So there are 20% of people who rated the Squid Games as 9. I mean, in the total population, there are 20% of the people thinks the Squid Game is 9, the rating 9. So there are 21.6% of people who thinks or who gave the rating 10 to the Squid Games. And if we come here, what do we understand? The 8% represents there are 8% of people who thinks the Squid Game is having a rating between 1 to 3. There are 6% of people who thinks the Squid Game is in between, or I should say the word like they rated it already that the game is 3. I mean, sorry, the video is 3 to 5. And there are 13% of people gave rating between 5 to 7. So that's what we understand from this relative frequency. Okay, now let us see an example here. The same, but it's applied to the Titanic problem, which we saw the last video. So there are, we are taking a sample of 714 members of Titanic ship. And in that, we see the ages, right? These are the age groups. So there, how many people, or we can say like, there are 30% of the people on the Titanic with age groups between 20 to 30. So there are 30% of people. And how many kids are there below age 10? We can say 8% of the population, 8% of the sample, they are kids of age 0 to 10 during the incident, right? And how many percentage of people are there with the age 80 to 90 is 1. It's 0.1%. Okay, very nice. So now let's go to the next topic, which is mean. How do we calculate the mean? So we know how do we calculate the mean. We calculate mean by, here we have, by applying average, right? Mean of group the mean of the ungrouped data is equals to average of, which is around 7.3. So now let's try to calculate the same mean for using, I mean, for the group data. We have two different groups, group data. Let us try to find out. Okay, in this, what's the formula we use? This is the formula. We represent with x bar or mu. And how do we calculate? X times f divided by f. What is x? If you remember, x is midpoint. So for here, we don't have upper limit or lower limit. So the x is equals to be the same class boundary. So we say x is going to be the same. But in this case, we have x. So the x is equals to the middle of the upper and lower boundary. Let's say average of these two numbers, these two. So this is the x we found it. I'm doing for the both the tables, this table and this table. And we need to calculate x times f. What is f? Here, let us say f. Oh, sorry, we already have f, right? The frequency. So what we want to do is x times f. So we want to multiply x and f. So x times f, which gives 69. So let's do it for the whole data, which gets me this. And also I'm going to do this for this data, x times f, which is equals to x times f. We got x times f. But what do we want? We want to add all these elements. We want to add all. We want to add them. So if you want to add, so what do? We do the sum. We do apply the sum. To do quick sum in Excel, what we can do is I press Alt and the symbol of equal sign, and it will apply the sum to all the rows above it. I mean, to all the numerical rows above it. Yeah. So we say this. So you got this is the sum here. This is the sum here. And let us calculate the mean. So what's the formula? This sum divided by this sum. The sum of all the frequencies is n. We already know it. Let me write here. We already know this whole is equals to okay. This whole thing we can write as n. We already know n is sum of all the frequencies. Okay. So what we can do is the mean. Is someone talking to me, or is it your microphone switched on by accident? Okay, I think that's an accident. Okay, please mute your microphone if you are not talking to me. Oops. I think she's away. Let me see. Okay. So let's find mean of this group of data. How do we calculate? Mean of the data. Result 1, group of data 1, and let's say group of data 1. I call this group of data 2. Call it the group of data 2. So mean of the group of data 1 is, here I'll calculate for 1 and here for 2. Okay, for 1 is sum of all x times f divided by the n. We know n is this one. So we do this. We got 7.34, which is exactly equals to the mean of the group data, I mean to the ungrouped data. And let us see for this one, the group data 2. The sum is this one divided by the sum of frequencies, which is n is this. So we got 7.8. So here we can clearly see when the group data is having a small interval, or here it is kind of 0, that means there is no data loss. But if you see here that there is a class width of 2 and we are losing some information, and this affects in our estimation. So we estimated a mean and we got 7.3, and which is very correct because we are not losing any data while grouping all the raw data. The group of data is very good representation of the raw data. But here we are losing some data, some information. We're not able to translate the complete ungrouped data into the this group data. It happens because let us say if there is a rating 2, this is good. If there is a rating 1, it goes good. If we say there are 1,000 ones and only 1 2, so but the average it takes like 2 for the whole 1,000, right? So it's very bad way of or we have a big error in this. But here the error is 0. So what we can understand is as we have less and less h value, we get more accurate estimate of the average value. I mean the mean. So what happens is, in this case, we can say we have no data error, I mean no data loss of data, because our class interval is 1, the h is 1, and also here the increment is 1. So we are not giving the rating 9.1 or 9.9. So we have 10 or 9. So we are changing in a steps of 1, and here the class is also changing at a step of 1. So we are collecting all the data elements. So here we understand that, right? So now let's do another example. Let's generate random data, group them, obtain mean from the ungrouped data, and we obtain mean from the grouped data. We obtain from ungrouped data and also grouped data. Same work what we have done here, we'll do it on some randomly generated numbers. So let's generate some random numbers. Some message, let me see. The mean of grouped data and ungrouped data is different because we are losing some data when we group the. I'm sorry, what's happening? So we lose some data when we group it, but in some rare occasions it will be the same. For example, here it is, we can call it kind of a rare occasion, or in some certain special conditions it will be the same, but not in every time. This is the example we understand. So this is the correct one, right? We collected from the raw, and if you see, this one is matching with this one, and here we have an error. This is a good estimate, but not the correct one. Is it clear? Okay, very good. Now let us generate some random data. So how do we generate random data? In Excel, we have this function random between. So let me generate some random data between some, say, 8 to 8,002, 95,000 divided by 1,000. So what I'm doing is I'm generating some numbers between 8 to 95. So let me collect some 2,000 data samples. Okay, so we have 2,000 here, which we generated some random numbers. Oops. 8,000 to 9,500. I wanted to do 95,000, right? Somehow we got it. So I copy and I paste values. Okay. I have some random data. What I'm going to do is I want to group them. To group them, here I don't know what is the maximum and minimum. Let me find the maximum and minimum. So maximum, minimum are, use Excel formulas, max, min. So we already know we generated numbers between 8 to 95. So that's what it's reflecting here. To get a better estimate and better calculations, we just don't take from 0. We just try to take as close as possible to the ranges. So we can take from 8 to 95. So let's divide 8 to 95. So let us see. Let's see what's the range. What's the difference between them? 95 minus 8 is 25 minus 8. Let us see. 95 minus 8, which is 87. So 87 is, let us see, let's divide it by 5 and see. 17.4 it says. Okay, let us start with 5 and add 5 to it. So we do this because we know the class interval should be 0, right? I mean, this constant. A class interval should be, if you say 5, it should be 5 for every time. So we say this one plus 5. This one is same as this. So if you fill this, we take class interval the same on all the classes. If you take any class, the class width is the same, 5, 5. Everywhere it is 5. So we say call this the lower boundary, we call this the upper boundary, and we want the middle. Let's calculate the middle at once. The middle one is middle of these two, we call it average. Average of these two is, let's see the average of the whole rows, all the rows, and then let us see and let's calculate the frequency. So what is the frequency? We already know how to calculate it. Let's do the same way. If this is a range, we want it less than or equals to this number. So it should be greater than or equals to this number. And then we say I'll show the formula again. All the data elements greater than this minus all the elements greater than or equals to this. So we get this number. So we fill all the classes and we calculate the sum. The sum is, we know the sum of the frequency is the number of data elements. So we click here, it says the data elements are 2000, right? So we should get 2000 here. So we distributed it. So it's until now it's good. So now let us see the next one, which says the formula. It says x times f, right? So x times f. To calculate the mean, we need x times f. X times f. Do this. So we calculate this and let's add the whole set. We got this number. So how do we get the mean? Let us see here. Mean of the group data is equals to this sum divided by the total population. Here in this case is 51.8. This is a mean of the group data. Let us see what is the mean of the ungrouped data. Mean of the ungrouped data is equals to average of, which is 51.773. So I will ask you a poll. Help me with this poll. The question asks, let me stop sharing this. The question says, which result is more accurate? The mean from the grouped data or the mean from the ungrouped data? Which result is more accurate? I'm getting a lot of results from both sides. There are still 5 people who didn't answer. Please think about it and tell me which answer is the most accurate. The one we collected from the group data or the one from the ungrouped data. Okay, so the answer, the people who says it is from the group data, can you please give an argument? Why do you say the data collected from the, the mean calculated from the group data is more accurate as compared to the mean collected from the ungrouped data? Can you please give some argument? You can raise your hands, or you can just unmute yourself and talk. Okay.
Can you do it? Sure.
So I didn't understand. Please explain again. I couldn't hear you what you said. Okay, can come someone from the other group? Can you explain why did you select that ungrouped data is more accurate compared to the grouped data? Okay, let me explain. Let me share my screen. Okay, so if we see here, the grouped data, we are collecting the information in groups. The frequency, we are losing some data. We have 57 population, which we don't know if they selected 5 or anything less than 10. Any number between 5 to 9.99 falls into this category. So we exactly don't know what is the number. We are missing the accuracy. But here we are taking the number directly. It's face value. You can take it directly. We are saying that each data element is giving some contribution for the exact calculation. But here the data elements are not giving direct contribution. So what we can understand from this is this data is a good representation but not accurate one. So this one is good but not accurate. And this one is the accurate one. This is a better result because it's more accurate. We are collecting from the raw data. But the problem is we can't have raw data all the time. The raw data is usually a lot of data. We can't have it on our computer screens all the time. So what we do is we group them, we distribute. So most of the time the data you receive in the group data. You receive something like this, right? Okay. So is it clear why the grouped data is not as accurate as the ungrouped data? Okay. So if you hear, let me see the message. Yes. Okay. Yes, very nice. So we see the mean, we solved an example. Let's go for the median. The median. So let me explain what is median. We already calculated median in the previous class, but let me explain again what is median. And based on the median, if we understand median, we can go for other calculations of other what we call the other information. For example, the quartiles, percentiles, and deciles. We can try to understand what are they saying. Okay, let me see what is median. Let me explain what does median say. The median says divide the whole population into two halves based on the variable you have. So for example, here the variable we have is the ratings. So I'm talking about the ratings, the Imbd ratings, right? So this is the Imbd ratings. We have a lot of data. So I want to divide the whole population into two halves. So let us say you have 1,000, let's say these are how many? 1,185 people. Let's say they are physically available in front of you. You made them stand in a order. The order, which order? The person who gave rating 1 is standing first. The person who gave rating 10 is at the last. So you made them stand in a long queue. So all 1,185 people are standing in a long queue. And you want to know the middle person, the exact center point, the middle person of the whole queue. What rating did he give? So you're not interested in a lot of other information. All you are interested in, if you organize all these people in a long queue, and what is the rating given by the middle person of this queue. So that's what we call the median. So median divides the whole population into two sets, the set above and the set below. So here is the formula. How do we calculate it? How do we calculate x tilde? We call tilde. We say this x, I mean the median, is equals to the lower boundary of the median class. How do we define the median class? The median class is the class which is having, let's say what we call this, which is containing the middle person. So how do we see the middle person? We organize all the humans, I mean all the population in a long queue, right? So we are doing that already in this frequency distribution. So let us see, let's not see this one because it's very obvious from this. So let us go with this group. So we see this group, right? So here we are already organizing them in a orderly fashion. So the 1 is on the top, the 10 is below. So we have the frequency. So what we want to know is, where is the middle person standing? So how do we see that? We create a row. Let me add few rows here, or let me remove this. Okay. The middle row. The middle row is sorry, the CF, cumulative frequency. Let's calculate the cumulative frequency. How do we calculate cumulative frequency? 8 plus 99, 8 goes 72 plus 99. Same formula applies until down. So this is the cumulative frequency. What does it mean? So if I stand here, there are 336 people above me, right? Including this one. So how do we see here is, we want the middle of the population. If n is equals to, n is total population is n. So half of the population is n divided by 2. So we know n is 1185. So half of that is 182.5. So we have to find out where is this half of the population falling on, in which class, in this class or this class, which class. If we put all them in an order, we can see 592 is falling here. So why? Because until here there are 336 people, but in this class we crossed the limit. So there is a rating between 7 and 9 which is having half. Okay, so we call this as the median class. So let us say I here, I representing the row 1 2 3 4 5. There are 5 rows, and we identified this is the M. M is the median row, median class. Median class is the M, right? So let's put this one as M. So how do we say M is equals to this one, which is 4. Okay, so we want lower boundary of the mth row. So let us see LM, lower boundary of M, which is the lower boundary of mth row, which is equals to 7. And then we need to calculate n divided by 2, which we already know. N divided by 2 is 592.5. Very nice. And we need Cm minus 1. Cm minus 1 is cumulative frequency of m minus 1, the class before that. If m is 4, m minus 1 is 3. So the cumulative frequency of the third row, is this one. So we calculate this. And then what we get, let us see what else we need. We need Fm, the frequency of the median class. The frequency of the median class is Fm. So what is it? The F of the mth row, which is this one. And then we need H. We already know H is constant, so we can take any two, any class, and we subtract upper boundary from the lower boundary, and we get the H. So if we have all this, we can calculate median, which is equals to, show the formula again, L plus n divided by 2 minus Cm minus 1 divided by Fm whole times with H. So let us say lower boundary plus the difference of n by 2 minus Cm minus 1. So this one minus Cm minus 1 whole divided by the frequency of the model of the median class, and times multiplied with the H. So we get the answer 8.457. So what is the median is 8.457. That's what we are getting from this group of data. So now let us see from this data. It is more easy to calculate median from this group data. Let me see if someone sent me a message. I got some message. I'm not sure what is. If someone is having a doubt, please you can ask me. Okay. So let's remove this. We are not doing this. Okay, let's remove this. We are not interested in this anymore. Let's remove this. Let's remove this. F. Let me calculate CF first, and then I'll explain what I'm talking about. Okay, here. This is the cumulative frequency. So what I'm saying is we want to just cut the whole population into two parts, the one above and below, and we want to know what is the point we can cut, or the person in the middle of the whole queue, what is the rating he given, what is the rating given by that guy. So how do we calculate is we first find n by 2, n divided by 2, we know it is equals to 592.5. so he's the one who is in the middle. So we see the population here. So where is the person who is in the middle? So he's at the 8. So we can say in 8 there are a lot of people who given 8. So if you put all of them in a queue, I mean all the ones, all the 1185, so you can see the person 592.5 is given the rating 8. So from here we don't have to do any calculations. We can directly say the median is 8. Median is 8. We can calculate directly because we know each number represents one of the data, when the data collected. So there is no points in this. So there is no sense of saying 8 point something, because we know the person in the middle selected 8 or 7 or 9 or any of those numbers. We already know that. So from this type of group of data, when the numbers are integers, we can exactly tell the person who selected is 8. The person at the middle of the whole population selected the rating 8. Okay, so this is the one from the group data. So let us say median from group data 1 and from the group data 2. We got median from the group data 1 is 8. Median from the group data 2 is 8.45. So what is the median from the ungroup data? The median from the ungroup data is equals to, let's calculate using the Excel formula, median of the ungrouped data is 8. See, so you know how Excel works. They put all in an order and then select the person in the middle, or the rating selected by the person in the middle, right? So that's how we apply this formula. Now let's apply this on the example we have made, the random data we generated here. Let's apply this formula. So let's remove this. Let me change this. Instead of mean, let me change to median. 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 Let us see what is the median of the ungrouped data, which is something very easy for me because I can just apply the formula. They select the data. It's 52.5 approximately, or I should say this is the accurate answer. 52.5 is the correct answer, right? And let us see what is the median of the whole group. So if we have, this is a group data, we don't want this information right now. Let me remove this. So instead of this, we want cumulative frequency. This cumulative frequency, the first one goes same. The second row, we add these two elements and then we complete the whole table. We get here. This is the cumulative frequency. The cumulative frequency, what we want to do is we want to find the median class. How do we define the median class? We divide the whole population into half. So we know, let me do calculations here. The n is the whole population, which is 2000. I'm getting from here the answer. So n by 2, which is equals to half of this, which is 1000. I have to see where is the 1000 lying. So here is 900 and something, but here is the 1000, because here it ranges from 937 to 1049. These are all the people standing in a queue. If we say these are 2000 people standing in a queue, the 1000th person is in this place, and we ordered based on these numbers. So the person associated with the 1000 number, and the 1000th person is in between 50 and 55. We don't know what is it. So we already, if you see this, the answer is something very close. We can say that. Okay, but anyway, we know the answer is between 50 and 55. So how do we? So we declare. Let us say this is the I. I is the row. I is the row. So the model row. Sorry, I'm using the word model. It's not model. It's a median. The median row is this one, right? The median row is this one. It's a 10th row. So let us say the median row is 10. So what we need to find? Let us find all the required one. The median class lower limit. So we have lower limits here. The median class lower limit is 50. So we say median class lower limit is 50. And then we need n by 2. We already have n by 2. I don't have to calculate. So we need cumulative frequency of the row or the class before the median class. If this is the median class, the class before median class is this one, and I want to find the cumulative frequency, which is cumulative frequency is 937. And what else I'm missing? FM, the frequency of the median class. The frequency of the median class is the frequency. This is the median class. So I'm talking about 112. This is the frequency of the median class. And then I need H. I know H is difference of upper limit and lower limit at any, you can take any class. It doesn't matter because all classes have same. So let me say somewhere here. Let me do it again. This one minus this one. So H is 5. The class height is class width, whatever we call, which is 5. So let us see what is the median. So median is equals to, we know the formula, lower limit plus open parenthesis, the difference between, or I should say CF, oh, sorry, n by 2 minus CF, n by 2 minus CF times H times H divided by the FM. So we apply that, we get 52.8125. 52.8125. Let me copy directly from here. So we see this value which is in red, which is very good approximation of this. So again, the question is which one is the correct? The one in the green is correct because we are directly calculating from the raw data. So remember, every time you calculate something from the raw data is more accurate compared to the one we calculate from the group data, right? Okay. So let me make a quick poll and let me see if it is clear to you. Okay, I asked you a question. Please answer it. Calculation of median or mode is more accurate on group data. Is it an yes or a no? Is it true or false? Yes means you agree to it. No means you don't agree to it. Okay, I see the majority is going towards no. The correct answer is no, because the calculations of median or mode is more accurate with the ungrouped data. When you are grouping the data, what we are doing is we are clubbing the data together, right? So for example, if we say 1 to 2, we don't know the person who selected is 1 or 2. So we are missing some information, right? So the ungrouped data is more accurate, but it is very difficult to work on such a huge chunks of data. So what we do is we group them. So grouping data is something not good, but we have to do it because the data is huge. Okay, very good. So let's continue with the presentation. So we understood what is the grouped data. We understood the grouped data, and also we understood the median. Now let us take the median topic to little further and extend it to the other places like quartiles, percentiles, and deciles. So to understand this, the concept is very similar to the median. So what are we doing in median? We are, let's imagine, let's go with the example of this Imbd ratings. So what are we doing here? We are organizing, we are putting all the humans, let us say these are humans physically present in front of you, like as I said before. So you are putting all of them on a long queue, and you are saying what is the rating given by the person at the middle of the whole queue. So you go at the middle of the queue and you select the person and you say what rating did you give, and he say here the answer is 8. So my next question is, so instead of dividing exactly in 2 halves, what about if you divide in 4 halves? If you divide in 4 pieces, we call them quartiles. If you divide the whole population, the whole queue, in 10, we call deciles. If you divide the whole into 100 pieces, we call them percentile. So the concept is very similar, but in median we divide or we break into the middle. Here in quartile, deciles, and percentile in different sizes of chunks. So let us see quartile, right? So let us see through an example. How can we do that? Let us see here. Let's try to find out in this example. Let me take here. So this data we have here, let me paste it here again. Let me organize this data in ascending order. So let me put this data in the ascending order. Okay, this data is in the ascending order. I will assign one ID to each of them. I don't have to assign, the Excel already assigned. This is 1, 2, 3, 4, right? So the total number of data is 1185. We have it. So what we said, what is the exactly middle? The middle person is 592. Actually, the number is 593 because we divide into half. It's between 592 and 593. So let us go there and see what happens. 500. So these are the humans in long queue. 593. Or anyway, so we can see all are 8s, right? The person here is 8. 592. That guy is selected 8. So instead of breaking into two halves, I want to make 4 pieces. And I want to see what is the first percentile, second or third or fourth. So here my question is the third quartile. So the third quartile, how am I going to do is first, so let me remove this part. So the let me remove the median. The quartile, right? The quartile is, how do we say, it's 4 pieces. The 4 pieces we need third quartile, so we need 3/4 of them. So we need 3 times n divided by 4. That's what I want. So we already know n, so we need to n times 3 divided by 4. So the percent I'm looking for is 888.75. So let us see where is this number going. So it is here. The person gave the rating 9. The percent quartile for 3 is 9. So how can we find out from the ungrouped data? We have to go to the row 888 and see what is the rating given by that guy. So we go there 888. So let's go 888. Let's go 888. Somewhere here. Okay, we can see this whole range is 9. So he is giving 9. The rating is 9. So the third quartile is 9. So if you want 84th percentile, so 84th percentile means what do you want? 84 times n divided by percentile is 100. So we have to divide the whole population into 100 and we are selecting 84th. So what we're going to do is the whole population times 84 divided by 100, which is 995. Where does 995 go? It is in this, is a 10. The guy standing at 84, I mean, if you take the whole population, you cut them into 100 pieces. The 84th piece, if you see, where are you cutting the 84th piece is 995. And that guy selected 10. So let's go there 995 and see what is the person who selected it. So 995, right? So we see it's all 10. So he selected 10. So that's how we calculate. So what is missing? The 7th decile. It's the same thing. The 7th decile is, okay, let me write here. 84 percentile is 10. Now the question is 7th decile. 7th decile is 7 times n divided by 10. So what do you call this? Number times 7 divided by 10 is 829. Where does 829 fall? It falls here and it says 9. So the 7th decile is 9. So 829. If you go to the 829 row, 829. So it is somewhere here, 829, and he is selecting 9. We see that, right? So that's how we get it. Okay. Now let us see from the group data, how can we calculate from this information? For this, we have the formula, we use the formula. But in the formula, as I said, we change LM and N by 2. Instead of LM and N by 2, we do some other things. What is the things we do? Depends on which quartile we want. For example, we want quartile 3, third quartile, right? So instead of n by 2, what we want to do is 3n by 4. That's what we want. 3n divided by 4. So instead of doing n by 2, what we do? 3n divided by 4. So we get 883. Sorry, 888.5. So where is 888? It is here. So the model class, the median class is 5. You have to select 5. The lower limit is 9. See, this all changing. And the CM minus 1, the one before is 688. FM. The FM is the fifth one, right? This is 497. 497. The H remains the same. And the answer is 9.8. You see, the answer is not very accurate. It's an estimate. So we calculated this result from this group data. So that's how we can calculate percentiles, quartiles, and deciles in a group data. If you have any doubts, please ask me. If no doubts, let me do for 84th percentile, and then we'll go to the next topic. So for the 84th percentile, what we do, instead of 3n by 4, we do 84 divided by 100. So what we do here we do 84 divided by 100. 84 divided by 100. It is 995. So again, it falls into this one, right? So all these calculations remain the same, and the answer is 10.23. So we already know the maximum is 10, but here it says 10.23 because when we grouped the data, we collected from 9 to 11. So there is an error. So if we take like a round figure, or we say take only the we can do, how do you interpret it depends on you. If you can take as a face value like 10.23, or if you want to put some effort and you want to make, say, okay, there is no number like 10.23, so let's make to 10, so you get the answer 10. So it depends, right? So this is how we do the calculations. Okay, now let us go to calculation of the mode. Okay, in the calculation of the mode, okay, so let me show how do we do that. Here we have the lower boundary LM, we add with the difference of, or you say the difference of the frequencies divided by the sum of two differences of the frequency multiplied with H. Okay, let me explain what is this. LM is, we call the model class. Model class is, what is the mode? The mode is the one with a lot of repetitions. So in the ungrouped data, we already saw the mode can be one or more than one numbers. But here in the group data, we calculate only one. So how do we begin is, we take the class with the highest frequency and we say that is the model class. So the one with maximum frequency, the frequency with the highest frequency, we call it the model class. In the model class, we take the lower limit, that's called LM. And what we're doing here, the frequency of the model class minus the frequency of the class before the model class, previous to the model class. We put it in the numerator. In the denominator, what we get, the same plus the difference between the frequency of the model class minus the frequency of next to the model class. We subtract that and we add it. We add these two terms and we get it, and we multiply with H. So let us do it through an example of the same Imbd rating. So let me delete this. And let me remove this. We don't want this. Okay. Again, for the mode, it is very easy when you have data organized in this what you call this, the classes with no loss of data. Here I said there no loss of data grouping. So here it is very easy to find the mode. What is the mode? By seeing the data, I can say the maximum is 257. So 10 is the mode. So we say mode of the ungrouped data, which we consider is the accurate, which is equals to mode having only one mode, and it is a 10. Okay, so mode of the grouped data mode of the grouped data 1, mode of the grouped data 2. So this is group data 1, this is group data 2, right? So how do we calculate the mode? Here we don't have to go for any formulas. Directly we can just say the 10 is having the most, and you can just say this one, because this is a hex, this is having the maximum, right? Okay. So I can make this kind of little automatic. How can I do is we look up these two, or better I select these two, such a way that the table array, oh sorry, lookup value, right? The lookup value is maximum of all this, and then table array I take like this, the column index 2 comma false, and say this here I put again the same one. So this is a formula to do it automatically. So what am I doing is we look up is it looks up for the data, the value I'm giving. What is the data I'm giving? The maximum. So because we want to find the model class, right? The maximum is 207. It's calculating, and then it says, tell me the second one. I mean, this tell me the second column. Select the second column. The second column is 10 because the first row should be the one which searches. So I'm doing in this way, right? Okay. I am sure there must be some other easy way. So let me type here, not to confuse more. It's very easy. Okay, now let's go to the group data when we are having some loss of data. So here to find the mode, what we say is find the model class. The model class is fixate M. The model class M is the class with maximum or see a maximum frequency. Which one is having the maximum frequency? If we see here, it is this, the I is equal to 5, right? And this is 5. The fifth class is the model class. So okay, so what are the information we need? The lower limit. The lower limit of the model class is 9. Another one, we want frequency of the model class. The frequency of the model class is 497. The next one says frequency of the model class before that. The frequency of the model class before that is frequency of the model class before that is this is this one 352. Then it says frequency of the model class after that one is after the model class, frequency of the class after model class is frequency of the class next to the model class is, we don't have anything, so we can say it 0. And h we know, which is difference between these two, upper limit and lower limit. We know it is 2 here. And now let's go to the formula. It says lower limit, so the mode is the lower limit, which is 9 plus, in parentheses we take the difference. We didn't calculate the difference, so let us wait here. Let's wait. Let's first calculate the difference. So what differences we want to calculate? So we want to calculate fm minus fm minus 1. So fm minus f minus 1 and fm minus fm. If you see here, these numbers should always be positive because fm is model frequency which is having the highest number. So any other frequency will be always less. So this will be a positive number. Also this will be a positive number. So let me see. This number minus this number. This number minus, here is a 0, so I think that's a 0. Okay, so the model or the mode is, now let me calculate again, the lower limit plus the numerator is the difference of these two divided by the sum of this one plus and sum of these two whole multiplied with the h is 9.4. So the mode of the group data, what we are obtaining, what we are calculating is around 9.4. So we say it is 9.4. We know the exact answer is 10. But what we are doing is, since we grouped the data, we are losing some information and we are getting 9.4 as the answer, right? Okay. So let us see an example. We already saw this example. Let me see another example on this big random data we collected. And here, let me remove this. We don't want them. Okay, let me calculate this. So I want to find the maximum value. So first, let me see model class. Model class frequency. Model class frequency is, how much is the model class frequency? We use the term FM, right? FM is maximum of all this. So what is this? 128. See, where is the 128? It is here. So the M is this one. This is M is 12. So M is 12. Okay. So now let's find LM. LM is the lower bound is 60. And then formula says we need FM. FM we already have FM minus 1. Let us see FM minus 1. What is it? The one before the model frequency, right? If this is the model frequency, the one before is 127. The one after one is plus, and this one is 123. 123. And then we need H. H, we already know it is difference between any of those two. Let us say, so which is 5. And then we have to calculate FM minus the row before and the frequency of the next one. So we need FM minus 1, also the next one, right? So let me do this. FM minus this one, and this one minus this one. Okay. Now the mode the calculation says we need to get the lower boundary less the difference divided by the sum of these two differences. Let me do like this. This one plus this one, and then we say multiply with the h. Then we multiply with the h, and the answer is 60.833. That's the model, right? So let me calculate the mode. So I mean, the mode is sometimes it will be very different from the ungrouped data and grouped data. The reason is because these we are calculating the decimals, right? So it is rare to find a model. So let me show how it works. Mode for ungrouped. Because when the data is uh, integers, it is very good. We can get it. When the variable is continuous, what do you mean by continuous? It has a lot of variables. It keeps changing. So there is a possibility there is two numbers repeating it, but which is completely lost when you take the upper bound and lower bound. So the result will be very different. So let me see if it is mode multiple. Let's see if there are multiple modes for the ungrouped data. Got stuck. I think it has a lot of multiple modes. Answer is 61. Oops. I think it's doing a lot of calculation. It's stuck. Somehow the what happened? Okay. Anyway, so the answer is 61 point something, and the mode we got is 60.8. All right. Okay. So now let's see what is variance. Okay. So variance, there are two different formulas. One is for variance in we call this the population variance, and the other one is sample variance. So if you see the numerator, it says is for the grouped data, and for the ungrouped data also we can see. For ungrouped data, you can directly use the formula of the Excel. For the grouped data, this is the procedure. Okay, what we do is we multiply the frequency times the difference between the mean and the midpoint, and we square it. So how do we do that? So let me remove this. Let us do directly the example, right? So let's calculate the what do you call this? The mean. To calculate the mean, we need to do xf, which is x times f. And we do this, and then we add it. This is the numerator, and the mean is this one divided by this one. So which is 51 point something, 1.8. So what we want to do next is subtract x, I mean the mean, minus the midpoint. So what we do, mean minus x. So we get, what do we get? Mean is this one. No, the mean is this minus the x is this, right? Okay. So we do this, and I want to copy below, so to not make the row change, I put a dollar symbol, I anchor it, and then let me copy until down. We get this. And then what we want is we have to multiply with itself, because we have to do square, right? So let's do square. Square. So this square means multiply the number with the same. So we get this. Okay. So the next step is to multiply with f frequency. So this one we multiply with, we can say, multiply the whole with the f. Okay. So we multiply with the f. We do this multiplied with the f. So we get this result. Okay. So what are we going to do? Then we have to add all of them, and that gives us the numerator. So we add all of this and we get the numerator. This is the numerator. And the variance is, so we have two variants. One is population, another is sample. Population variance another is sample variance. So population variance is this sum divided by the total number of data elements. And this variance is this divided by total data elements minus 1, which is this. Right? Okay. So here we can observe the sample variance is always greater than the population variance, and the result of variance is always positive because we are squaring it here. There are some negative terms appearing here, but when we square, it becomes all positive. So you have to observe that. And another thing is some books use, instead of mean minus x, they use x minus mean. It doesn't matter which way you use for calculation of the variance because we are squaring it. Once we square, it becomes positive, so it is not a problem. So we have this and we add it, and then what we do, we divide it. So we divide with the whole population or 1 minus the population, which we call the sample. So we are dividing with a little lesser number, so this value is always bigger than this number, right? Okay. So this is the variance. So now let's calculate. These all are from the group data. This is for the group data. Where is it? Group data. This is for the group data. For ungrouped data, ungrouped data, what we can do is, let's calculate the mean, which is average. And then we see the variance. Variance for 616, which is very close, very nice. This is population, right? Another variance from this, we get 16.5. So you can see, let me copy these two. So this is the result. So if you want to do by yourselves, what you have to do is something very similar to what we did here. Instead of frequency, we don't have to multiply with frequency. You have to just leave it and then you can do it. What I mean. So the same calculations we have to do. We have to just remove the frequency. So what we have to do, x bar minus x. X bar is the what do you call this x bar? The average or the mean. So we say mean minus, here the x is this one, the variable. So we get this. Then we have to do this times with the same. So we get this. So let me do this calculation for the whole population. We have this one, right? This one is this part. We have to remove the f if it is ungrouped data. So what we want to do, if we want to calculate the variance, what we do is sum of all this divided by n. N we already know, which is 2000. Let's say it's 2000. Okay, here I have to anchor this, otherwise it won't anchor. So I have to put anchor here. I don't want to move it. So let me calculate again. So this is the number we are getting. So if we do the same with one population less, so the one population less means 2000 minus 1, something similar to this. So we see the results are very close. Okay, so that's how we calculate the variance. Now let us see how do we calculate the standard deviation. So how do we calculate standard deviation? If you see, the calculations are the same, and instead of what is the difference between variance and standard deviation is we have to apply the root. So we are calculating sigma square. What we need is sigma. So let me remove this because it's kind of not correct. Because you have to apply the square root, right? Okay. So the standard deviation is sigma, which is equals to square root of the variance. So we already have the variance. So we want to calculate the standard deviation. What are we going to do? We just apply, let me take this data down, square root. Let me do, so instead of population, let me calculate standard deviation. Standard deviation. This also have for population. And then there is for sample. Okay, so how do we do this is square root of, and for the throughput data, let me see what happens. Let me calculate it. So the calculations gives standard deviation of population of this one. This is 24.8, okay, and standard deviation of sample is okay. Here. So we see the answers are similar, very similar. That's how we calculate the standard deviation. So what do we understand from the standard deviation is also it is a positive number. So what we can find from standard deviation, it's always a positive number. So here the variance is positive and we are calculating standard deviation as a square root of something positive, which is also positive. We are taking only the positive part of the square root. So it is positive number, right? So we saw the example. Now let us go to the multivariables. So before going to the multivariables, I want to spend 1 minute to see if you have any doubts. Please tell me if you have any doubts until here. Okay, if you have any doubts, please tell me right now, or else you can proceed to the next topic, the multivariables. Okay, so I see there are no doubts right until now. So in the multiple variables, what we can do is, now we have, or all the calculations what we are doing are for one variable, which is x. So instead of just one variable, we want to do multiple variables. So what do I mean by multiple variables? We have x. Let me take another one called y. This is x. Let me call another variable y. Let me generate again random numbers between 5 to 95. So calculate some random numbers, right? So paste the number so it won't change. So have this is y and this is x. So what am I going to do right now is I want to okay, instead of doing in the same page, let me do in the another page because it will help me to deal certain things. Let me create a new sheet. Here is sheet 1. So let me copy the whole sheet and paste it here. Here I'll take only one variable. So let me remove this variable. Here I take only one variable. I don't have to repeat the whole calculations again. So this is, let us say, variable x. This is variable x. This is variable y. So we have two variables, right? So when we have two variables, we can do some calculations. And what are the calculations we can do? We can find covariance and factor of correlation. What does it mean? The covariance. This we do on the individual data elements. We don't want to go for the group data. We just do on individual data elements. So let me remove this. Let me remove this. Okay. So we have X data, Y data. Okay. Before going that, I want to plot these two and I want to see how it looks, right? So let me take the whole data. X here, this is X. So 2000 data, so let me go to 2000 and I'll copy all of them. This sheet. And then I'll put the B column with the Y data. Do this. Instead of X, let's say Y. Okay. One question why I'm doing like this is when you get the data, you get in separate sheets. So when you prepare your data, it is always a good idea not to disturb the original data. Let the data be like this. And whatever manipulation you want to do, it's better to do in one completely entirely new sheet. So you have a new sheet, we have the data X, data Y. And then what I want to do is, let me write here X and Y. And then, this is X, this is Y. I want to plot X and Y. So how can I plot is, there is a scatter plot. So let me insert, this is a scatter plot. If I plot here, so it shows how these two are related or not related. Since we generated random numbers, they are kind of not related. You don't see any relation. You see? So these two data, there is no relation. They're just everywhere. If there is any relation, you can see that there is some pattern there. You don't see any pattern. The dots are randomly placed. It is very obvious because we are selecting the random variables. So let us see this. So how let's calculate the covariance. How do we calculate covariance is we find the mean of the first and mean of the second. So first variable mean and second variable mean. So let us say mean of x, mean of y. So mean of x is equals to average of whole. And this one is average of the B, right? So this one, the average. This is average of x, this is average of y. And then what we do x, the mean minus xi. So what you see, mean x minus x, and here we do mean y minus. So mean x, which is this one, minus x, and here mean y minus y. We don't want these terms to move. So one of the ways to press F4, it will automatically anchor it for us. We did a wrong anchoring because I want to anchor it to the other one, the H. So here, and I'll anchor here. Okay. And then I'll copy for the whole set. So we got the whole. In this one, the sum, and we have to multiply these two and then we have to add them, right? So let me multiply. So multiplying of these two. So let's say these two, I'm not putting anything on the top. Let's just multiply. We multiply it. Okay. Let me put so that we don't confuse. What we are doing here is we are multiplying these two. So one is mean x minus mean x minus x, another is mean y minus mean y minus y. So when we multiply, we get these values. If you see here, the values can be positive and negative. It is possible to have positives and negatives. So you can expect a result to be positive or a negative, right? Okay, so once you have this, and then you calculate, you have the mean, you have this multiplication, then you have to add them. The say numerator, say numerator covariance. The numerator of the covariance is sum of this is the sum of, this is the numerator, and the denominator is total number of elements. I know the answer is 2000. So let me calculate the, what am I doing here? Population covariance. Here we call it sample covariance formula. Here we get the answer is population covariance is this numerator divided by 2000 is 14, and sample covariance is same numerator divided by 1999, 1 less than 2000. So we get this value. So let me calculate and see what the Excel gives. Covariance, the population is, need to select X. Okay. Is the same as what we calculated, you see. Because we are working on the raw data, so the answer from the Excel and our answer should be matching because we are using the same data and same calculations. And the covariance of the sample is the same, 1 less than the whole. So this is from the formula, Excel formula, and this is from our calculations. So that's how we calculate the covariance. And we did this example. And now let us see little quick what is the covariance. Let's understand. So the covariance is the relation between two variables. So if you have any relation between two variables, the correlation will be very high. So if both are increasing at the same time, So we have a positive correlation. If we are decreasing, if one is increasing and another one is decreasing, we have a negative correlation. And there is possibility of getting 0. It means there is no correlation, there is no relation between these two data. And another important thing we have to understand is the correlation doesn't mean causation. What does it mean? So if you see the sales of ice creams when it is very hot, and also the sunburns we are having because of the heat. So if you see, like if we try to see the data, just the data of ice cream sales and the sunburns, and we say, okay, whenever there is ice cream sales, there is a sunburns. So we try to think that the sunburns are causing because of eating ice creams. That is a possibility of thinking that way when we start interpreting the data. So we should not interpret that the correlation is causation. Means ice cream doesn't cause sunburns. Those are two completely different things, but they both are having same cause. So we have to understand correlation is not causation, right? Okay. So let's try to find out what is the correlation between these two data. We know these two data are randomly selected, right? But first we'll go and see what's the formula. The correlation formula is the rho or R is the covariance of x and y divided by the standard deviation of x times standard deviation of y. So let us see what is this. Correlation constant. The correlation constant is correlation coefficient is this one, comma, this one. We see the value is very close to 0, 0.02. We can see there is no relation between these two data. These are randomly generated data, right? So let me change this data to something else. You see that data is having some sense, and their correlation constant is going to be little closer to 1. How? The data is changes, the correlation constant changes from 1 to -1. 1 means the relation is positive. I mean, if one value increases, the other one increases. The 1 represents there is a linear relation. -1 represents the linear relation in the negative sense. Means one increases, the other one decreases. So what I'm going to do is I'll generate x here, and the y is going to be, I'm going to put a formula, x times 3. So we know it is a linear relation, right? So let me see. So what is y? Y is 3 times the x. So once we plot these two graphs, we can see there is a linear relation. We plot this. You see it's a straight line because I made up the values, right? So let me see by putting some other values. Instead of +3, I'm going to put some negative value, -13, for example. So if I do this, we have a negative relation and the correlation constant is -1. See that? So what we can understand from the factor of correlation is the value takes from 1 to -1, and the positive means we have a relation when one grows, the other one grows. The negative sign represents when one is decreasing, the other one is also decreasing, right? So this is all I wanted to tell for today. If you have any doubts, you can ask me. Time is already done, but you can still ask me if you have any doubts. We clarify your doubts and then we end the session. Please tell me if you have any doubts. Okay. Anna, please ask your doubt.
Yes, I don't know if it's just me, but I can see the presentation on Blackboard. This presentation.
This
I just see
presentation is not
the
on the
decision
Blackboard.
materials from other teacher.
Yeah, that's right. Okay, I will upload this as well. At the end of the session, I will upload the presentation, right?
Okay,
It's
thank
not
you.
available yet. Yeah, yeah. Thank you for pointing me out. I forgot to upload this. Yeah. Any other questions? Any other suggestions? Okay. Thank you very much. Let us meet in the next class. I'll upload this presentation to the classroom.
Thank you.
Thank you. See you. Okay. Thank you. Have a nice weekend. See you. Thank you. See you.